So the next session is about the 6G public network services. We have two speakers. First speaker is Patrick Valdemar. Patrick has joined Telenor in 2002 and is the Vice President in Telenor Research. He has more than 20 years of management experience in education with strategic management, strategic marketing and information technology. He holds a PhD in telecommunication from NTNU and a Master of Management from the Oslo Business School. And he has been head of Telenor's research for the next generation network technologies, focusing on 5G and 6G. I welcome Patrick, and then I will introduce in the next speech, I will introduce Eric Hardwin. So Patrick, welcome. I give you the floor to start your speech.
Thank you very much, Nancy, and good afternoon, ladies and gentlemen. Today I want to talk to you about 6G for a sustainable future, and that's a little bit challenging when you have seen so many good presentations earlier, but I'll try to build on some of them and see where we come. So before I start, let me just give a brief introduction to the Telenor Group. Telenor was founded back in 1855 and has evolved from a Norwegian incumbent into an international mobile operator. And currently we are in 8, or per definition 9 markets, counting in the sales process ongoing in Myanmar. And being in these markets are of course quite different, being in the 4 Nordic markets and in the 4 markets in Asia. Telenor Research, which I've been heading up this department of next generation technologies, was founded back in 1967, and we'd worked on numerous innovations dating back to the first satellites, being part of both GSM and MPEG and the standard developments, working on the Opera browser, spinning out the company on that one in the 1990s, and over the last 9-10 years we've been working on 5G, and lately the three last years on 6G. In the Telenor Group, the role of research is to give advice and to challenge. And I hope that through this work, we provide a lot of good value to the Telenor Group. You know, Andreas Miller gave a really good presentation on how we have seen the various mobile technologies evolve. This is one dimension of it again, and the point here is that when we come to 5G, we start to see the technology for verticals. And I do agree, we need to continue to evolve it through the release 16, 17s, and also into the 6G part. And maybe more important than a lot of the functionalities here is that we actually need to increase our focus on sustainability. So when we look into what do we expect for 6G and for a sustainable future, we need to look at, okay, so how are the services that we see today, and how will they evolve? And what learnings can we see from the 5G rollouts that we need to improve to get into more sustainable solutions? And in my presentation now, I would like to look into this by looking into some of the 6G visions, some of the challenges, and some research directions. So, in my view, there are a few things that are more important than others when it comes to making 6G for a sustainable future. The first point is about resource usage. This is about, of course, the energy consumption, the material usage, the recyclability, and how we're enabling an operational efficiency through full autonomy. The second item is about empowering society through targeted society and industry communication solutions, addressing, for instance, the global divide. The last item is about innovation. It's about open innovation, and it's about standardization. We believe in one global standard, and we believe in industry collaboration, accelerating innovation through open source and open interfaces. You know, having seen all the presentations earlier today, I am not going to go through these white papers, but I want to take one thing that is common for all of them. They are all driving the increased use of data, which again will drive our energy usage, which again leads to a very high need to optimize and to look for how we can run this in a sustainable manner. So the challenges that we need to look into for a sustainable future is, of course, the 17 sustainability development goals, and I'll come back to a few of them in a second. It is to ensure security, trust, and resilience in our solutions. And we will need what I call super flexibility. Our systems need to be both flexible and automated. When it comes to supporting the various UN sustainability goals, I want to here just point at 3 of them. So number 9 is about, the industry, innovation, and infrastructure. This is about creating R&D collaborations on 6G technologies and innovative applications. It's about creating robust and shared infrastructure for communications, data capture, processing, and storage. And it's about finding a few and very innovative solutions. For instance, looking more into how we can use 6G solutions for navigation, positioning, location-based services. When it comes to sustainability goal 10, reducing inequalities, 6G should enable the use of advanced communication technologies, like advanced versions of AR, VR, for enhancing the living and education. It should improve the access for information and knowledge to the disadvantaged segments of society, and 6G should enable access to information and social networks to promote social and political inclusions. Last, when it comes to the climate actions, I think our future systems has a lot of various roles. The future communication services need, as I said, to be energy efficient. And the future communication services need to support those sectors that will need to be optimized, like smart transport and cities, like the smart buildings, like smart working, living, and health. And we need, as a communication sector, to look actively how we can contribute in the various aspects. So when it comes to research directions, we need to look into some important enabling technologies. This is like, of course, has been mentioned before, spectrum efficiency, the use of terahertz frequencies, AI networks, and cloud-native architectures that needs to be further evolved. We need to look into the consumers and verticals. 6G should be designed to enhance the support of industry verticals as well as supporting the new consumer needs. And to get this all together, we need to do more research on understanding future roles, partnering options, and societal impact for future 6G services. So when it comes to the enabling technologies, I think they can be divided into two types. On the evolutionary side and on the new and radical side. Within the evolutionary side, we find, I think, continued evolution towards machine communications. We need to also have a continued focus on security and trustworthiness. And as mentioned before, we will look more into high frequencies and new radio technologies. Within the more new and radical side, we find the native AI, we find the joint communication, sensing and positioning, and we'll find new network architecture. Then I think it's worth noting that in 6G, even more than in 5G, everything will become software. And with this comes the need to be able to develop sustainable software components. So my key messages on 6G for a sustainable future is the following. We need a 6G vision with focus on resource usage, empowering society, and open innovation. We need to challenge ourselves with regard to supporting the UN sustainability goals, security, trust, and resilience in our solutions, and the flexibility in our solutions. And to support this, research is needed on enabling technologies, consumer and vertical industries, and we need to look more into 6G ecosystems. This was my presentation, and I'm looking forward to taking questions later on. Thank you very much.
Thank you so much. Thank you, Patrick. We will have the questions after the second speech. So I would like to introduce Eric Hardoui. Eric is the director of the Ambient Connectivity Research Domain of Orange, which investigates future access and transport networks and technologies, as well as the related business models. He also has led the research on wireless networks in Orange. And Eric holds a PhD degree in signal processing and telecommunications from Telecom Bretagne and the University of Rennes 1 in France. And he has been with Orange since 2004, where he has conducted research on interference mitigation for mobile networks. Eric, we look forward to your speech and the insights from Orange. I give you the floor.
Thank you, Nancy. Hello, everyone. So I'm pleased to be here with you today. So let me share my, my slide. Okay, can you see my slide?
Yes, it's perfect.
Okay, excellent. So thank you very much. So yes, so the title of my talk is 6G for Society, because indeed in Orange we have the strong belief that 6G should provide value to the society while being sustainable in all the meaning of the terms, being socially, economically, and of course from the environmental perspective. So what do we expect from 6G? Well, basically, we expect three main types of benefits. The first one, as I just said, is to provide value to the society and foster innovation. The second one is to support what we call societal requirements, and I will come back to that later. And the third one is especially important for us operators. It's to satisfy operational necessities. And I'm sure that David this morning, when he gave the perspective from NGMN, highlighted this point very much. So 6G is obviously for the 2030s, and today we are in the research phase. But still, as you know, there are several disruptions which are about to reach the real world and the real networks, which are listed on the right-hand side of the slide. The 5G standalone architecture first, that we plan to deploy from next year and mostly from 2023 for I would say, large-scale commercial deployments that will arrive with virtualization and cloudification, particularly for the core network, but also for parts of the radio access network, especially through Open RAN and RAN desegregation that we have mentioned also previously. And also it will bring edge computing into the network, and all those different disruptions. Obviously, we will need to learn from them, from the field operation, and they will also be integral parts of the 6G system. And we need to take into account the lessons that we will learn from their commercial operations when we will design the 6G system. That being said, there are a number of technology disruptions, particularly on the radio side, and I will not detail them because I'm sure that they have been discussed early today already. And from also the technical capabilities, or I would say from the performance that we can expect from those technical capabilities, we engineers, network engineers, we are thinking about potential applications. What can we do with those further increased capacity data rates that will provide value to the society? And there are some ideas, particularly about using those new capabilities to improve what we have already with 5G, or what we will get with the 5G standalone architecture, particularly regarding industrial applications with critical communications to control robots, for instance, on a factory, or to allow some autonomous cars, as we discussed previously. Then we have also some potential new disruptive applications like holoportation, which is about the communication of the 5 senses, not only the vision and the sound. So more immersive communications in general, and also massive digital twins to have digital representations of a large number of objects with very high definition information about those objects being updated in real time, again for industrial applications, but also for health, for instance. So these are, I would say, very general directions for possible applications that will be enabled by 6G. But again, we are at the beginning of the 6G design. And what we need to do, and that will become especially important in, I would say, 1 to 2 years, when we will start putting together the different building blocks of 6G to create a system concept. Well, we will need to have a better view about the services that we want to offer with 6G, because as usual, when you are building a system, you need to make choices, design choices, and often that involves trade-offs. And in order to set those trade-offs right, well, we will need to have a good idea of the applications that we really want to deliver with 6G. And in order to do that, we are convinced that we cannot do that alone with the telecom sector. We need to do that jointly with the future users of the technology. And I was very happy with the previous session, where we had representatives from different sectors who are users of the technology, and for which mobile technology with 5G will become more and more adopted. And this is something that we will, of course, that we need to expand with 6G. And the good thing with 5G is that we have put in place some good relations between the telco world and the worlds of various industrial sectors that led to 5G AA and 5G IA, for instance, 5G ACIA and 5G AA, sorry. But of course, this is not enough, And also we need to strengthen those links that we have with automotive sector and manufacturing sector. We need also to strengthen the links with other verticals for which we don't necessarily have a association that represent them today. So that is true for the industrial sectors, but that needs also to be true for the citizens and for the administrations. And in order to get inputs from what those different stakeholders need from the future telecom systems, well, we need to establish a dialogue. And how to do that, it's yet an open question. I mean, there are ways like those associations that we have mentioned, but there are also other ways. But we need, whatever the way, we need to create those links to make sure that from the one hand, we get inputs from the needs of the future users, and that also we can get feedback from them based on the technological proposals that we will offer from the system design. And what is also extremely important is that we use those links to provide information, to update the public and the future users about what the technology will allow and also what it will not allow. For instance, we had this remark earlier about the fact that we have heard a lot about 5G, but 5G today is mostly about using a smartphone with the typical 4G services. And I will say that yes, but that was what was planned. In NGMN, when we designed the 5G requirements from operator perspective, we said that, and that's written in the 5G white paper, 5G will not come in one piece. There will be several stages, and each stage will bring certain innovations, but the full 5G promise will not be realized from 2020. But probably we have not communicated this sufficiently well, because also we get some similar feedback from customers that what 5G delivers today is not exactly what was promised. But I mean, for us who designed it, we're just following the plan. And so there is this need for setting the expectations right for the future users of the system. And also it's important that we provide clear, I would say, scientifically based knowledge also about the technology in order to avoid some fake news that we had in the past years about what 5G would do. I'm sure you've heard that some people think that the COVID-19 vaccine is an opportunity to inject some 5G chips into the bodies. And well, that is a little bit far-fetched, but some people really believe that. So we have a problem also with the perception of the technology from at least some people in the public. So making sure that we have that we deliver the correct information to the outside world is, I think, a major stake for the future. So once I have said that, identifying services that will provide value to various sectors, being industrial or just societal in the wide sense, is extremely important, but that's not enough, because then we need to make sure that we have the right building blocks from the technology perspective to, of course, offer those services. But we need also to make sure that those services that will be feasible in a way which is economically sustainable, in the sense that they will not force us operators, for instance, to deploy antennas every 50 meters, for instance. Of course, that would not be feasible. And also we need to make sure that they will be sustainable from the environment perspective. And that brings me to what we have called those societal requirements of 6G that cover several dimensions. But one of them is the end-to-end environmental impact. And you know that in 5G, we have put a lot of effort in improving the energy efficiency compared to 4G. But that's not, environmental impact is not just about the energy consumption while the network equipments or the terminals are in use. It's also about the carbon footprint of those equipments, including their manufacturing phase and also their end-of-life phase. And each new equipment that we are manufacturing generates some carbon equivalent emissions. And in the global stake of reducing the greenhouse gases emissions, this is something that we need to take into account. The good thing is that 5G and furthermore 6G will be excellent tools to fight the climate change by helping different sectors of the society to limit their greenhouse gases emissions. But in the end, it's also a trade-off between what the technology will allow other sectors to save in terms of carbon emissions and what are the carbon emissions that will be generated by the technology. And I think we need also to have those trade-offs in mind when defining the technology. And then, of course, we have requirements about security, resilience, digital inclusions. And there is another one that maybe is less common to hear about. It's about the EMF. You know that we operators, we are subject to limits about the radio waves that we are allowed to transmit in order to respect some exposure limits, which are recommended by the World Health Organization. But it happens that there are some places, like specific cities or countries, who adopt much lower limits compared to what is recommended at the international level. And in those cases, it can be difficult for us to add new frequency bands. And so far it was okay, but now with adding 5G on top of 4G and 3G, 2G, then we are getting closer to those particularly low limits in some particular places. And that means that if we don't change the way we transmit radio waves, then we may just not be able to deploy new frequency bands, particularly when we will be in position to deploy the 6G networks that will obviously also use new frequency bands. And that calls for new ways of transmitting signals in such a way that we can still improve the capacity of the networks, improve the data rates, but while not increasing in a significant way the EMF exposure. And there are technologies to achieve that, like the reconfigurable intelligent surfaces, for instance, or those ambient backscattering devices that just reuse waves which are present in the atmosphere and modulate them to improve the performance of the networks while not creating additional radio waves. So, I mean, we have those requirements, but the difficult part of it is to create clear indicators in order to provide design targets to guide the technology design. And of course, we need solutions in order to then meet those requirements. Still, that provides very important research directions. Then, regarding the operational necessities, from the operator perspective, it's extremely important that we have flexibility in the way we can activate some specific features of the network. As I said, there will be certainly some trade-offs to be decided, and we would like, I mean, we will need there will be some trade-offs that we will need to solve at the system design phase, and there will be some trade-offs that we would like to have the possibility to tune with the operators depending on our needs. That will be different from country to country, from city to city, between city and rural environments, depending on the day, I mean, depending on the hour of the day, between day and night, and so on. So that calls for flexibility in the network in order to set those trade-offs according to the need. And also, we need flexibility to be able to upgrade the network, adding new functionalities for new needs, for instance. So the technology needs to be flexible enough also to be able to evolve several years after the initial deployment. We know also to make the network as easy as possible to be operated. And while the technology, the complexity is dramatically increasing, we need support for that. And AI is providing an excellent way of helping our operational colleagues to run the network. But that also needs full system monitoring, because in order to apply AI to manage the network, then we need to have a lot of data about the state of the network. And that calls also for being able to monitor all the aspects of the system. So to conclude, what we need to do is to identify some services, and we hope to do that with you who are representing different sectors of the society, because we have this objective to define a technology that will bring value in all the possible meanings, whether it's economical or from the environment perspective, or just for the comfort or for health or whatever. And in order to do that, we need to have those strong relations between us, the telecom community, and the future users of the technology. As I said, we need to define societal requirements in addition to performance requirements, and the technology building blocks that we will include into the 6G system. Then we need to meet both those performance requirements, but also societal requirements. And we cannot do as we did in the past, which is to optimize the network or the technology for performance, and then wonder how we can tune it in order to satisfy less energy consumption or better security. No, we need to take into account those requirements from the start. And at last, we need also to establish this dialogue with the society at large to collect needs, feedback, and also to ensure the correct flow of information between us and them. Thank you very much.
Thank you very much, Eric. Very interesting. In fact, your presentation tackles or is close to one of the questions I have received related to how ready the operators are to address the diverse requirements from the vertical sectors. Also taking into account that you will have probably high requirements for reliability, availability, liability, and you have put also the dimension of the sustainability, which is quite tricky, I think. Do you see somehow a potential roadmap in order to address this, at least to start addressing these first, let's say, high-level requirements?
So coming back to the initial part of your question about how ready we are to address the requirements from verticals, well, that's, I mean, having a technology adopted by as many players and users as possible is, of course, excellent for us operators, because we see that as an opportunity for new customers, new business, new revenues. And the 5G standalone architecture that, as I said earlier, we plan to launch widely commercially from 2023 with some initial, I would say, targeted deployments in 2022 will be a tool for that, because it will allow us to, I mean, using the slicing functionality to offer private networks, leveraging the public network infrastructure. So providing more or less the same experience to an industrial customer as if it has deployed its own network infrastructure. Also, of course, because it will use the public network infrastructure, it will be much less costly. And we will have the tools in order to do that, and to do it in such a way that it will be much easier and less costly to do for us, because this is something we can do today already. And this is something that we actually do in France, because you may know that the network for the police in France is using the Orange public network infrastructure with some specific parameterization for giving a higher priority, for instance, and higher quality of service. So this is something we can do, but today it is extremely complex to do. It's a project of its own, and it needs a lot of people to work on that. So we cannot offer that to everyone, or it will be extremely costly. So very few companies would have the resource to afford for such a service. And slicing will allow us to reduce the cost for offering that kind of private service over the public network infrastructure, and so it will allow us to offer it to a much larger number of customers. So we are fully ready to offer services to industrial players. And then regarding the timeline for defining the requirements of 6G, well, I would say that the work is ongoing right now, particularly in some research initiatives across the world. For Europe, particularly in the EXA-X project, where we are active on this topic. But this is a complex problem, so I assume that it will still take several months and possibly years in order to clearly define indicators together with the target values for such requirements. NGMN will play a role in that also, because next year NGMN will work on defining the operator vision for the 6G requirements. And if I remember correctly, the goal is to deliver the requirements by the end of 2022. So there will be some efforts across the globe for doing this. And it should come quite soon. Thank you.
Thank you very much, Eric. There is also a question to Patrick. Patrick, just a quick answer if you can. It's about the high frequency, how this can help for sustainable future. More nodes, less efficient power amplifier.
Yeah, I'll take a quick answer. You know that the high frequency link to the sustainable future is more that we need to pay attention to the energy uses also here. So in itself, high frequency is a challenge with regards to energy usage, and we need to look more into how we optimize that and hence do more research.
Thank you so much.